my name is Söke Dinkla. I'm the director of the Lehmbruck Museum, and I'm very glad to welcome you here in our museum. I'm very glad that you decided to make your conference here at the Lehmbruck Museum. The organizer asked me to draw a short line between the history of our museum and the content of your conference. I think this will be quite hard.
We are proud to have the Käte Hamburger colleague in general and this midterm conference here now, because the Käte Hamburger Institute or colleague is a very important institution for our university, the University of Duisburg-Essen. The University of Duisburg-Essen, if you don't know it, it's one of the youngest universities in Germany because it has been a merger of two formerly independent universities, University of Duisburg, University of Essen. It rapidly developed since the merger 12 years ago, and we now have more than 40,000 students.
Colleagues and friends, I would like to mention 4 points in 5 minutes. A welcome and thank to all of you who came from Germany and abroad to this conference, also to the musicians we have. I don't know where they are. Thank you very much for the jazz standards. And of course, thank you very much for being here in this Lehmbruck Museum. It was impressive in this impressive hall. The interesting thing about our colleague is that it has a kind of self-reflexive aspect to it. So we study and do research on cooperation, but we are also kind of an example how scholars, scientists cooperate. And this is an interesting group, I can tell you. I would like to introduce tonight's very distinguished keynote speaker. I'm very happy that you made it to Duisburg. So we are looking forward to his keynote address to us. He is, as you mentioned, what we should do. He is also an advisor to a lot of organizations, particularly international organizations like the United Nations, the World Bank, the International Task Force on Global Public Goods, the OECD, and the European Commission. And he was, which is for me an interesting aspect to his curriculum, he was one of the lead author of the second assessment report of the IPCC panel. We will tonight have a keynote address by Scott Barrett, and after that we will have a discussion, a first commentary by Margret Thalwitz. She is also a fellow, or let's say an ex-fellow, but I think you're always present in our colleague of Käte Hamburger colleague in Duisburg. And then we have questions and answers, and the whole session will be moderated by Dirk Messner. I wish you an interesting evening and an interesting conference, and have a nice day in Duisburg. And if ever you have the opportunity, please check a bit more of this museum. Thank you.
Lovely. Well, thank you very much. I think I'm going to write my contract to say that before I give any speech, I must be given a tour of a splendid museum. I have to be able to see nature because I'm a professor of natural resource economics from the podium, preceded by wonderful jazz music and surrounded by good-looking and warm intellectuals. Okay, so that's my new contract. This is a great pleasure. Can you hear me okay? I have a slight feedback back here. This is a great pleasure for me for many reasons, but this is my favorite topic, and as you said, I share that with the center. And I'm going to try to open up a world to you, a way of seeing the world. You know, we had some of us, about 15 or 20 of us, were treated to an incredible tour of the museum by a very engaging, articulate, and passionate tour guide. And she did what all tour guides do. She would take us to a piece of art, and we would look at it, And at least me, I was puzzled sometimes by what exactly I was seeing, or maybe I thought I knew what I was seeing. And then she would start to tell us about what was really there. And every time she would tell us something new, I would see something different. And by the end of the tour, I felt I had seen things in a way I didn't understand before. And the way I work is somewhat similar, at least my aspiration is somewhat similar. When we look at the world, we almost always can agree on the facts. What we can't agree on is what's behind the facts. Why is it that things are the way they are? Why aren't they better? How do you tell if things are going well or they're going poorly? These actually are very complex matters of the mind and the imagination. And the way to do it, I think, is to use everything you can, a bit like some of the artists we saw. I use little mathematical models. Why? Because they show me things I could never have found on my own. I read history, of course. I think about images. I talk to people. I talk to actual negotiators. One of the most exciting things I've done in my career is to work with Professor Astrid Dannenberg doing experiments with people. In these experiments, I can test what the theories are telling us. Basically, you have to use everything you possibly can to try to understand what it is you think you're seeing. So what I'm going to do is try to take you through some of that. Because this is a research center, I'm going to tell you a little bit about how I do the research, but I also will be telling narratives that I think should be comprehensible to most people. I do have a PowerPoint. I wasn't aware that I was going to speak in such grand surroundings, and maybe I would have designed the talk slightly differently, but you can imagine that you're not here at this lovely museum, you're in a university hall, and you have an old professor here, and he's going to dust off a PowerPoint. Okay. Now this, by the way, this is the worst slide I have, so don't panic. It's not going to be an ordeal. You'll be okay. The paradigm of global public good, and a lot of the things we care about with international cooperation are global public goods. These are things that, when they're provided for one country, are available to every country, whether that country helped with the provision or not, and that's the problem. Because you create within these kinds of situations a conflict of interests. And this is what we are witnessing when we see, for example, the climate negotiations meeting again and again and again and again. And even when everyone can agree on what everyone should do collectively, it seems no one can agree on what to do. And certainly no one does what's necessary. And why is that? It's not for lack of trying. It's, I think, because we are approaching it completely the wrong way. So I'm eventually going to move towards that. But this is the paradigm right here. And it's the paradigm of the prisoner's dilemma. And in that picture on the left, this is an image. So think of this as a work of art. I hadn't planned to do it this way. But think of this as a work of art. Okay, it's not a very good one. But think of it as a work of art. And what you have on the bottom axis there are the number of other countries that are cooperating. And the example I have, it's a pollution example, and these are the countries that are abating, cleaning up their emissions. And on the vertical axis, you have a measure of value which reflects what the players in these games are countries, what they care about. What they care about. So the higher you are on the vertical scale, the happier you are. The lower, the less happy you are. And what you see, there are two lines inclined, moving from the left axis to the right. And the one on the top is the payoff that a party gets by polluting. And the one on the bottom is the payoff a party gets by cleaning up its pollution. They both increase, which means that each player is better off the more that others clean up their pollution. But because the payoff to the polluter is always higher than the payoff to the abater, each party would most like that everyone else clean up their pollution and that this party not clean up its pollution. That is how the prisoner's dilemma works. So you're drawn toward the left-hand side where no country, in an extreme case, no country is cleaning up its pollution. And on the right-hand side, every country is. And the key point is that the motives of countries are very conflicted here. The individual incentive is to move to the left. The collective incentive is to move to the right, to get everyone to cut back on their emissions. And when you see that image, the one thing I want you to remember about it is those two curves, those payoff curves, they never cross. And that's the problem. So this is the image, this is, I'm afraid, the work of art I have to offer you. The problem is those curves which reflect the national interests of various countries, they don't cross. And because they don't cross, you're always stuck with this conflict. So that's why countries meet repeatedly, and that's why those negotiations often fail. Not always, and I can explain why they succeed sometimes and why they fail. Well, Professor Dannenberg and I have done experiments. This is an example of an experiment. And we had, in this case, a group of people, 5 people in a group, playing a public goods game. So a game much like I just showed you before. And on the left hand, on the vertical axis, you have the number of players that are contributing. And on the horizontal axis, you have the number of times they're playing the game. So on the left, they start playing the game, and then they keep playing, moving to the right. So what happens there, we have 5 players, and what you see on the far left, at first, 3 of these players abate. They do what's in the collective interest of the entire group. 2 of them don't. The next time they have a chance, only 2 of them abate. So the numbers cooperating are coming down. The third time they get to do it, only 1 is doing it. And by the time they get to the 4th effort, no one is doing it. Cooperation has completely collapsed. When you get to the 5th effort, again, no one is doing it. Okay, then we ask the group, try again. Do it again. Next time around, 2 of them, 2 out of 5, contribute. Then just 1, and then 0, and then 0, and then 0. No one's cooperating. By the way, these people are playing for real money, so they have an incentive to do this properly. That's why they keep trying to go up again, but they're being drawn down. It's that tension between wanting to cooperate and wanting to get the best outcome for yourself. The third time they try, 1 party is left cooperating, the others are not. And after that, that party says, I'm not going to bother, you aren't doing it, no one does it. And for the rest of the game, no one contributes anything. In my view, that is an image of the climate change negotiations over the last 25 years. We've basically achieved nothing. For all the effort and even goodwill, we've achieved nothing. And when you ask why, I think, of course, there are multiple reasons. Of course, it's complex. But at the very heart of this problem, like a lot of these global challenges, the central problem is this conflict of incentives. Okay. Now, we have institutions. Why? The reason we have institutions is that they restructure the relationships we have with each other. That's true of our social institutions, our domestic political institutions, and it's true of our international and global institutions. And in the international realm, the ones that we normally think of would be norms, which tend on the informal side, treaties, which are analogous to contracts, customary law, which is a kind of a background international law that applies universally, Security Council resolutions by the United Nations, and so on and so forth. These are all institutions. Why do we have them? Well, we have them because the games that we're playing leave us worse off, because we cannot control our own instincts. And the institutions are there to try to channel our behavior, basically to try to manipulate how we want to behave, and they essentially change the rules of the game. That's their purpose, and when they work well, they succeed. We do behave differently. When they work badly, we don't behave differently. And the reason that the institutions at the international level are so interesting to study, but also so disturbing when they fail, is that the primary institution behind the entire international system is the nation state and the notion of sovereignty. Now, sovereignty is not a given. It changes over time, but countries only give up sovereignty begrudgingly. They don't like to do it. And I think analytically, the main way we should be thinking about these problems is how can we get countries to cooperate, even subject to the constraints of sovereignty. Another part of our minds need to be open to the idea that if things get very bad, countries might be willing to give up a little sovereignty. They have in the past. They will in the future. But they tend to do it after every other effort has been tried and failed, and when they don't see alternatives. And as an example of how sovereignty affects things, if you were to negotiate a treaty to bring about an outcome that's going to be better for everyone, well, under the rules of international law, countries are free to be in or not. That's sovereignty. So participation is voluntary. We don't run countries that way. If there's a domestic law, it applies uniformly across a country, and a majority decides. In a democracy, well, the international system does not work like that. What does a treaty have to do to succeed? Very simple. It has to do three things. First, it has to get the countries that are important to participate. So they do ratify, they do participate. Second, it has to get the countries that participate to comply, to do what they said they were going to do. Third, it has to get the countries that are in the treaty and comply to do something important. It's very easy to get 2 out of 3. You can have a treaty, for example, that doesn't ask anyone to do anything. You get full participation, full compliance, but what good is it? We have a lot of treaties like that. Okay? One of them is the Framework Convention on Climate Change, but we have a lot of treaties like that. You can have a treaty that asks countries to do a lot, and then they don't participate. Look at the Non-Proliferation Treaty. The countries that aren't participating are precisely the ones that have nuclear weapons outside the treaty. So this kind of thing happens again and again and again. The hard thing is to get all 3. 2 out of 3 is not good. Okay, here's another. So the picture on the left is the one I showed you before. That's the Prisoner's Dilemma game. And as I said, the problem is those curves going upwards don't cross. The picture on the right shows you an image in which the curves do cross. Now, where does that image come from? That comes from a little model that I wrote down in 1989 that introduced an institution of a treaty. So you took the basic prisoner's dilemma, which is how countries would interact when they act independently on the global stage, as it were, and what the picture on the right shows us is how that behavior would change if you make available to them the opportunity to negotiate a treaty. And the essential thing to notice about that picture is that the curves cross somewhere in the middle. That's where you're going to get a certain number of countries participating in the agreement, a certain number of countries not participating. But you notice the vertical lift you get above the 0 line, it's very tiny. So you get some cooperation, you have a treaty, there are countries that are participating, but they're not doing very much. That, I think, characterizes a lot of cooperation. Now, what are the main insights you get from this kind of model? Well, when the number of countries, I call that N, when the number of countries is large, think about global issues, treaties tend to achieve very little. I'm going to give counterexamples, by the way, so don't walk out yet, because I know this part's fairly depressing, but I'll give you some other examples. If the participation level happens to be high, you might think, well, that's good. But actually, what normally happens, participation is high because the countries that are doing something would have done it anyway. The treaty is not really changing their behavior. Sometimes you get a treaty that will cause countries to change their behavior, but the participation level is very low, and so the result is not very useful. The basic problem is that when you're dealing with global issues and you're trying to confront the prisoner's dilemma game, what you need to drive behavior is some means for enforcement. So countries actually want to do what they know is in their collective interests, and the reason they want to do it is if they don't, others will punish them for not doing it. That's how all the good agreements work. For example, the World Trade Organization works partly because if I don't live up to my side of the bargain, you can punish me by imposing countervailing measures against me. That's how the design works. Of course, because I know you will do that, I tend to stick to the rules. And that gives reassurance to everyone, which is the ideal situation we're always looking for. Well, here's an example in which cooperation worked. So having said that cooperation is difficult, I want to give an example in which it worked. This is an example from history, from the 18th and 19th centuries, primarily into the early 20th century. There was a resource called the North Pacific Fur Seal Treaty. There's a drawing in the top part there, rather cute in the drawing. And they were actually harvested. They were actually an important resource at one time. Their pelts were used to make furs for women. You can see an image on the right. They were quite popular, and when large herds were discovered in the Pribilof Islands, especially in the 18th century, this was like a discovery of gold. These pelts were so valuable, and you had ships coming in from different countries to try to kill the seals. And countries with their own breeding populations tried to stop that. But the problem is the seals would spend part of the time in the waters. And the territorial limit was 3 miles, 3 nautical miles from shore. And so once the seals were outside the 3-mile limit, under international law, anyone could kill them, and everyone did. So the numbers of the seals were plummeting, and there were widespread predictions of extinction. By the way, the nature of conflict was so great, believe it or not, over the fur seal, there was concern that the competition for the fur seal might bring about war. There were people who were killed over this, including by the militaries. So it was actually something that could have flared into a serious situation. Well, there were many efforts at cooperation over many, many years, decades, and every single attempt failed until 1911. And then a treaty was written. It's a short treaty. It's a lovely treaty. It's only about 4 or 5 pages long. And that treaty, that 4 or 5 pages written on a piece of paper, changed everything. And there was a complete transformation, and now all these countries cooperated fully. How did it do that? The treaty did 5 things. The first thing it did is it banned killing seals at sea. You couldn't do it anymore. It banned that. That allowed that meant that the only killing was done from countries that had their own breeding population, and they wanted to manage those populations to maximize their own payoff, as it were. And so you were sustaining essentially full cooperation. The second thing it did is it required that the countries that had the breeding population give a certain percentage of their take to countries that didn't have. So there's some sharing. That was important because that made sure that everyone gained from the agreement. So you can think of the first thing as creating a pie, the second part dividing the pie in such a way that everyone is better off with the agreement than without the agreement. The third thing it did was to enforce participation. How did that work? There were 4 countries that were exploiting the seal, and the way the treaty was written was if any one country were not to participate or to pull out subsequently, the entire treaty would collapse. Well, if the treaty collapsed, you go back to where you were before with open access in which the fur seal was going to extinct and all the countries were going to lose, and no one wanted that. So because the cost of cooperation failure was so severe, should one country pull out, the entire agreement was kept together. The fourth thing is the treaty enforced compliance. It actually did this by leveraging off of domestic institutions. And the fifth thing it did was to, and this is the very important thing, it deterred entry by third parties. You see, if the 4 countries had succeeded in cooperating, you could have just had entry by other countries to kill the seals beyond the 3-mile territorial limit. We see that in fishing all the time. But the reason this worked was because it turned out all the first seal skins were processed in London. And the furriers in London had a unique process for turning the furs into, the raw furs into coats. And if you couldn't export to London, it wasn't worth killing the seals. And Great Britain was in the negotiations, negotiating on behalf of Canada, because Canada wasn't quite adult at that time. And it's because of the trade restriction that that agreement worked. So these are very, very special conditions. You don't get that today with most global fisheries. And so this is really an exception that proves the rule I said before about cooperation failing when you confront a prisoner's dilemma type problem and the number of players is large. This succeeded because the number of players involved, you could shrink it to just 4 countries. I'm probably taking too long, so I'm going to skip over. I was going to tell you something about fisheries agreements today, but I think I'm going to skip over that, and I'm going to move on to a global environmental problem that became known to us in 1974 when an important scientific paper was published in the journal Nature, and this concerns depletion of the ozone layer. So this image here, which I think is probably the most important in the environmental area, is a computer-drawn image of ozone concentrations over Antarctica. And if you could see in the blue the outline of Antarctica. And this is the famous ozone hole you may have heard of. This particular image was based on satellite readings taken on the 2nd of October 2014. That was the last maximum size of the ozone hole. The hole closes up every year and then opens up in the Antarctic spring when the sun shines again. You have a very complex chemistry in that one part of the world that causes this incredible depletion. And at the top there, I showed the Montreal Protocol. This is a treaty that is, like the First Seal Treaty, one of the most ingenious ever developed. It took a problem that actually could have been quite severe, including resulting in tens of millions of deaths, and turned it into a great success. So how did it do that? I'm going to show you another one of these pictures. Now, this picture here on the left is like the ones I showed you before, but now the curves are crossing in a different way, and this is very important. One aspect of the Montreal Protocol is that it includes a trade restriction between the countries that are in the agreement and the countries that are out. And this is a very important part of the treaty. And the way it works is if let's say that no one else is in the agreement and you decide to come in, well, you now have to cut back on your emissions of CFCs, the chemicals that deplete the ozone layer, which you're inclined normally not to want to do because of the prisoner's dilemma. Okay? On top of that, because of the way the treaty is written, you can't trade with the rest of the world. So it's almost as if you're doubly punished for doing the right thing. However, look at the other side of the image on the far right. Suppose that every country is in the agreement and you're wondering, should I be in or not? If you come in, you have to reduce your emissions, which normally you don't want to do because you'd rather free ride, or at least there's a temptation. But now you can't trade with the rest of the world. And that's an extra cost. And if that cost is big enough, if the loss and the gains from trade are big enough, you'll want to be in. And that's exactly how the Montreal Protocol works. And the beauty of this is the treaty works because it threatens trade restrictions, but every country is in, every country has cooperated and complied fully. The ozone hole is being repaired, is expected to go back to its earlier levels by around 2060. All of that has happened without trade ever being restricted. It's the credible threat to restrict trade should a country not cooperate that motivated that behavior. The reason you don't hear very much about this agreement is because it works. It's a funny thing. You only hear about things that don't work. But actually, if you want to learn how the international system works, you need to take all the data you can. And this is an important example. This good-looking man, his name is Ali Malin. And he is famous. He is to me, and he probably should be to you, because he is the last person on Earth to be infected with what's called endemic smallpox. He became infected in October 1977. And when he got sick, he went to his flat, and the smallpox is serious illness. But he didn't want to be found out. And fortunately, his friends were concerned about him and went to check up on him and found him in his flat, saw immediately that he had smallpox. And the smallpox eradication effort offered a reward to anyone who turned in someone who was infected. And his friends, well, you know, friends are friends, said that Mr. Mallon had been infected, and the eradication effort then moved very quickly to isolate him, put him under 24-hour armed guard, vaccinated everyone around him, people who had been in contact with him, and then vaccinated the people who had been in contact with those people who had been in contact with him, and then vaccinated the people who had been in contact with the people who had been in contact with the people who had been close to him, and so on and so forth. And had this not happened, in October 1977, the world would not have eradicated smallpox. It would not have worked. You only need the virus to exist in one human for it to spread everywhere. So this colossal effort to eradicate smallpox, which really began with an intensified program in 1966, was basically on a knife edge in October 1977. And because this one individual was identified, this disease was eradicated. The benefits of this have been enormous. So in my calculations, this is the best public investment the world has ever made in history. And it's an astonishing achievement. It was not achieved by a treaty, by the way. In fact, you don't want a treaty for a problem like this, which is interesting. It used a different institution. It used a resolution adopted by the World Health Organization. You normally think of these resolutions as being unimportant because they're non-binding. Not true. For this particular problem, that's all you need. In fact, that's the institution you want. Okay, so here's another one of those pictures. And again, what you have on the horizontal scale at the bottom are the number of other countries that are eliminating the disease within their borders. You have the payoffs on the vertical scale, and you've got these two look like horizontal lines on the top there. The one at the very top is the payoff a country gets when it controls the disease but doesn't quite eliminate it. And the one on the bottom is the payoff a country gets when it eliminates the disease. Now, when you eliminate the disease, it doesn't exist anywhere within your country. But you have to vaccinate to a very high level to get there. And what happens on the far right, that's where everything interesting is going on. The far right, you'll notice that that bottom line, that bottom horizontal line jumps. And the reason it jumps is that if every other country eliminates the disease, and then you eliminate it, your action, combined with their action, will guarantee you eradicate the disease. If you eradicate the disease, it will be gone. When it's gone, no people in the future will become infected. And when this program began, over 1 million people were dying every year of smallpox. No people will be infected, and no one will have to be vaccinated. That's important because the vaccine was expensive, but more importantly, the vaccine had side effects. For example, 1 out of 1 million people vaccinated would die. There were a number of complications associated with the vaccine. So here was a tremendous success, and the reason it works is that this game, like the one I showed you before for the Montreal Protocol, causes these curves to cross in just the right way. They convert a game that would have been similar to a prisoner's dilemma, and they make it what's called a coordination game. And that is an absolutely fundamental point. Everything I've learned about international relations, international cooperation really comes down to this, and that's the main message I want to convey. When the world sees a problem, imagines a problem as involving coordination, we succeed. When we confront a problem as a prisoner's dilemma and try to get countries to behave in their collective interests without paying enough attention to the conflict with their self-interest, we fail. Okay. Exception was the First Seal Treaty, but in most cases we fail. Now, one thing that happens in that game I just showed you is that it depends on the action of the last country. So it's not good enough. If you have 100 countries, it's not good enough that 95 cooperate, or even 99. You need everyone. In fact, for eradication, you need every community, every family, everywhere on the planet to cooperate at the same time. I mean, come on, imagine that. And there's no tolerance for any error, no tolerance at all. This picture I showed you here shows you warlords and rebels in Somalia some years ago. It's interesting. Ali Malin, lived in Somalia. Now, he became infected, as I said, in 1977. At that time, Somalia had a stable government. Suppose we tried to eradicate smallpox later. It's not 100% sure we would succeed. We had a window of opportunity there. There's another program underway now to eradicate polio. That program began in 1985, was supposed to have been concluded by 2000. It almost succeeded in 2000. There were only a couple hundred cases that year. And you know what? It's almost succeeded every year since then. We get really, really close, not quite there. And we have not had the Ali Malin for polio. We've not had that. Interestingly, Mr. Malin died 2 years ago, and he died when he was actually working on the polio eradication effort. So he dedicated his life to this. Polio is a fascinating topic to look into if you want to understand international cooperation. This image here is a map of where polio cases are today. On the bottom, on the left side there, in West Africa, you see Nigeria. Nigeria, so far this year, has no cases. When I say Nigeria has no cases, what I mean is no cases have been found. It doesn't mean there aren't no cases. This is very important, because if we don't find a case, but it's there, okay, that's bad. Okay. And they're very hard to find because only 1 out of 200 people infected show any symptoms. So this is a very hard disease to find. It's not like smallpox. Smallpox you can see very easily. Polio you can't see. If you look in the upper right, you'll see yellow areas. The yellow everywhere in that map indicates the country is still being endemic with smallpox. But you can see little red dots in the upper right. Those are the polio cases that have been identified this year. And those cases are in Afghanistan and Pakistan, primarily in the border regions. And what's going on there? That's where you've got the most dysfunction, the least trust. This is the weakest link right now in the global system. And you see it in this map when you look at the effort to eradicate polio. I'm not sure about my time, but I think I'm going to skip this one and talk about climate change. Okay, this is a provocative, I mean, it's an exciting image. You may not be able to see it very well. That's the Statue of Liberty. 20 meters of sea level rise, at least. Lightning, torrents, complete catastrophe. I wanted to get your attention. You know, there's the risk, climate change. There are two kinds of climate change. One is gradual, which is this kind of slow unfolding of climate change where things get progressively warmer. That warmer air temperature triggers other changes in precipitation and other things, but it's all fairly slow and linear and gradual. Not the kind of change in climate that would attract a Hollywood producer. They want something that's really dramatic. They want something that happens very quickly. Okay. Well, we have the first climate agreement was negotiated adopted in 1992. It's the Framework Convention on Climate Change. And in that agreement, the world agreed that we should limit concentrations of greenhouse gases in the atmosphere at a level that would prevent dangerous interference in the climate system. Now, it turns out that every country in the world is a party to this agreement. So the world agrees we should avoid danger. Okay, that's a good start. Of course, they didn't agree at that time what danger was, and they certainly didn't agree on how to do it. We're still working on that. Now, later we have meetings all the time on climate change. In Copenhagen, in 2009, as most countries agreed, and this has been affirmed now by every country, that it would be wise to limit mean global temperature change worldwide to 2 degrees Celsius. So that now is the collective goal, and countries do agree on that. But you know, it's easy to agree on a collective goal. Why? Because no one's responsible for meeting it. The harder part is agreeing on what individual countries should do and then creating the incentives that make them want to do it. And that's been the problem. That picture I showed you before of the 20 meters of sea level rise that probably happened within 3 hours, so to create the right atmosphere for a Hollywood blockbuster. There actually turns out the scientists have identified a number of possible tipping points in the climate system where you get a big switch in a major geophysical system. One example, there are many, but one example would be melting of ice over Greenland, some of which might happen gradually, some of which might happen a little more suddenly. But basically, the understanding of Greenland right now is it probably would take thousands of years for all of Greenland to melt. That would involve 7 meters of sea level. That's quite serious, although over such a long time horizon, I'm not sure exactly how it should be characterized. I call it catastrophic, but always use the quotation marks to indicate I'm not really sure. You have to decide for yourself if that's really catastrophic. But this is the kind of thing, and there are many other examples, that people are worried about today. Okay, I'm going to now make you do some work, and then I will wrap up after this. But you're not going to get up lightly, because I'm a professor and I like people to work, and I'm not the only one who's going to work tonight. So I'm going to ask you to imagine playing a game. This game works very much like the pictures I've been showing you, but now I'm going to ask you to think about it in a slightly different way. So imagine you're one of 10 players playing this game. And each of you is given 10 black poker chips, okay? And you can contribute any number of chips. You can think about putting those chips into the middle of the table, the middle of the room. And you're going to get a payoff, and so will everyone in this game. And the payoff is you get 10 cents for every black chip you keep, plus everyone in the room gets 5 cents for every chip contributed, okay? So this is how the payoffs work. Suppose that you contribute 4 chips and everyone else contributes 45 chips. So that means 49 chips contributed in total. Your payoff would then be 10 cents for every chip you keep, and you're keeping 6, so that's 60 cents, plus 5 cents for every chip contributed by anyone. 49 chips were contributed, so your total payoff is €3.05. All right, for these numbers, what's the best the group can do? The best the group can do is for everyone to hand in all their poker chips. But what's the best for an individual country to do, or a player to do? Even if everyone else hands in all their poker chips, if you hand in yours, you get €5, but if you keep yours, you get €5.50. You get more by keeping, and that again is the prisoner's dilemma. So what's happening in that game is those payoff curves I showed you before are operating in parallel. They're not crossing. They're not moving in the right direction. All right, now I'm going to introduce something else, another technology. In that earlier picture, I showed you a windmill. That's kind of, think of that as ordinary abatement. I saw some windmills on my train ride here today. On the bottom right here, I have a different technology. This is called an air capture machine, and this machine takes CO2 directly out of the air. Some people think it would be dangerous for concentrations of greenhouse gases to pass 350 parts per million. Right now, they're 400 for CO2. They're 400. So we've already passed the danger sign, the danger line, as it were. The only way to deal with that problem is to take the CO2 out of the air. This machine will do that. The thing about this machine is it's expensive. But some people think to avert dangerous climate change, this is what we need to do. Now, let's look at this game now. Before you had the 10 black chips, now you're going to get 10 red chips. So the black chips are for the windmills, the red chips are for these air capture machines. And your payoff is going to be, you get 10 cents for every black chip you keep, just like before. And now you get €1 for every red chip you keep, because the red chips are worth more. But for every chip you contribute, everyone in the room gets 5 cents. Now what happens here is, when a player contributes a red chip, it costs that player €1. It gives everyone in the room only 5 cents, and there are 10 people in the room, so the room gains 50 cents, but it costs you €1, so it's best you actually hold on, for the group, you hold on to your red chip. But the reason I brought in the red chips is because the reason we're thinking about those expensive machines is we're worried about catastrophe. We're worried about maybe needing to bring parts per million down to something like 350. Okay, this is the last complicated slide. So now I'm going to introduce this idea of catastrophic climate change. So suppose there's a threshold out there. This is what people are worried about with climate change. There's a threshold. We don't know where it is. If we cross the threshold, we're going to get in serious trouble. Okay? That's what motivating, that's the dangerous aspect of the climate negotiations. So suppose the threshold is 150 chips. We've got 10 people in the room. Each person has 10 black chips, 10 red chips, so 200 chips in total in the room. If fewer than 150 chips are contributed, we're going to cross that danger line. And then we'll suffer catastrophe. And catastrophe in this game, I'm calling 15 euros. So every person in the room loses 15 euros. So now suppose that everyone else in the room contributes no chips at all. Then what's the best thing you can do? Well, the best thing you can do is also to contribute no chips. Why? Because you personally lose for every chip you contribute. And no matter what you do, you can never avert catastrophe. It takes everyone to avert catastrophe. So suppose everyone else contributes 15 chips. Now what should you do? Well, that means that they've contributed 135 chips in total. If you contribute no chips and you do the math, you get 2.75 euros. But if you contribute 15 chips, you guarantee that catastrophe does not occur because everyone else has contributed 15 chips. And now you get a payoff of 12.50 euros. So if you do the right thing, you get a higher payoff. Now you see that your self-interest is consonant with the interests of everyone. That's a coordination game. That's what we need to find to deal with these enormous collective action problems. Now, the problem with climate change as a real problem is that this concern about catastrophe, real, but the thresholds that trigger catastrophe are deeply uncertain. We don't know where they are. I've read all the science. I talk to scientists all the time. It's just a fact. We don't know where they are. We're playing an experiment with Mother Nature. We don't know what's going to happen. So the key thing is, how does this game change if you have uncertainty? Well, this picture here came out of some research I did with Professor Downenberg. And what you see on the horizontal line is the extent of uncertainty about where the threshold is. So in the game I described, I said we knew the threshold was 150. We knew it. It's certain. Well, that means you're on the far left where the 0 is. There's no uncertainty. As you move to the right on the horizontal line, the bottom line there, uncertainty is getting bigger and bigger and bigger and bigger. Okay? And on the vertical line, again, this is an aggregate level of abatement. Now, what happens here is if uncertainty is very small, you're in that blue zone on the left, that's where you have a coordination game. And that's where everyone's going to want to do the right thing, contribute their chips, and make sure the catastrophe is avoided. To the right of that line, that dividing line, you're in the pink zone, and that's when you're back into a prisoner's dilemma. Uncertainty is so large that no one's going to be inclined to want to contribute. Why? Because my own contribution there, because of the uncertainty, is unlikely to be decisive. So I'm going to decide to hold back, and everyone's going to be holding back too much. So the strong prediction of this little model is that to the left of the dividing line in the blue area, countries will coordinate perfectly and will avert catastrophe, and to the right, they won't. And unfortunately, by the way, the real problem is on the right. But I want to see, in working with Professor Dannenberg, I want to see, do real people behave the way the model predicts? So we did an experiment with real people. Well, these were undergraduate students at the University of Magdeburg. I call them real people. I'm sure their parents do as well. So what you have, and again, they're playing for real money. And what you have, again, on the bottom scale there from 0, 20, 40, 60, 80, 100, that's the extent of uncertainty about the threshold. And on the vertical scale, you have the contributions. And the model predicts, so if countries cooperated fully, they'd be moving along that black line. So as uncertainty got bigger and bigger, people would be contributing more and more chips. You can think of this as the players wanting to obey the precautionary principle. As uncertainties got greater, they wanted to make sure that things did not get bad, and they would be contributing more and more and more. The red line is the prediction from game theory about how people would behave. And you'll notice on the left, and those dots, the green dots are the proposals that people make for what everyone ought to do. That's a bit like countries agreeing we should avoid 2 degrees centigrade climate change. The yellow dots are the pledges that individuals countries make for what they will do, and the dark blue dots are the actual contributions. And what you see is, just as the theory predicts, the dots stick to the black line to the left of the dividing line. Once you get the dividing line, the proposals and pledges dip down a little bit, and the larger the uncertainty, the more they dip down. But what really changes are the actual contributions. So I want you to think about negotiations like the Kyoto Protocol, or negotiations coming up in Paris in late November, December, countries pledging to do various things, and the question is, will they actually do it? Okay? And what this experiment is suggesting is, if uncertainties about the threshold are wide, which they are, then we should be concerned they may not do it. Now you'll notice that the dark circles don't fall too far, so it looks like even though they change abruptly at that dividing line, you might say, well, actually they didn't fall all the way to the bottom, so it's not that bad. But what's going on there is that those black chips are very cheap. So if a student contributes 10 black chips, you get almost to the level of where those blue dots are to the right of the dividing line. It only costs those students 50 cents. That's nothing. What was expensive were the red chips, and that's what they're not contributing. But if we're to avert dangerous climate change, this is very important to remember, we have to contribute expensive chips. It's not going to be cheap. To stabilize greenhouse gas concentrations, you have to bring emissions to zero, which means we have to stop using fossil fuels, even when they're cheap to extract and use. And we have to do this worldwide. And this is completely without precedent. The world has never done anything like this before, ever. Don't underestimate how difficult this is. Okay. Now, the next meeting of the Conference of the Parties will be in Paris, late November, December. And countries are submitting what are called INDCs. These are intended, nationally determined contributions. You can think of them as poker chips. Intended. Well, I wake up every morning intending to do all sorts of things. I don't know about you, but I don't always do them. These are intended, they're nationally determined. I determine what I'm going to do, you determine what you're going to do, and so on and so forth. No one else is determining them for us. And that's what countries are contributing now. What's novel about Paris is that there's going to be probably a review process. So you're going to see how many chips I'm proposing I'm going to throw in, and you're going to find out whether I throw them in or not, and then hold me somehow to account, although everything's voluntary. That's the arrangement that it looks like we're heading towards in Paris. So we're relying on something like naming and shaming for contributions, and I want you to think about whether that's going to be enough to bring about this radical transformation that we need. I should tell you, by the way, I happen to have met with the 2 co-chairs for the Paris meeting, and I asked them if they thought this review process would make a difference. And they were very quick with their answer. They both told me, no. I think what we need is strategy, not the approach we're taking now. Yeah, this is an image from a famous movie about mutually assured destruction, but I want to think about it a little differently. So imagine we're playing an experiment. Okay, so you have to use your imagination in this business. So imagine that, remember that if we have a certain threshold, you have a coordination game and everyone will work together. So let's do this. If Mother Nature won't give us a certain threshold, let's create one. So let's wire up all the nuclear warheads to a computer that's taking a reading of concentrations of greenhouse gases in the atmosphere above Mauna Loa in Hawaii. I told you that the level today is 400. Let's say that when it gets to 500, all these weapons will be detonated and no one can stop them. Okay, I am almost 100% sure if we did this, the world would limit concentrations to 500 parts per million. Now, I'm not proposing that we do this, but by the way, this idea is analogous to the so-called Doomsday machine that Herman Kahn had come up with to prevent nuclear war. I'm not actually proposing this, but I do think as a mental exercise it's useful, because this arrangement would change behavior fundamentally. There are other approaches we could take. William Nordhaus, an economist at Yale, has proposed trade restrictions in something called a climate club. My own idea is a little different, and it is trying to build in coordination, which I told you is the one thing the world is good at. Smallpox eradication, a coordination game. The way we phased out CFCs to protect the ozone layer, a coordination game. Okay? We need to exploit what we're good at and not going back and back to the table as we keep doing on climate, trying to get a different result by doing the same thing over and over again. It's not working. What we can do is we can take this big problem and break it into smaller pieces. So one example is there's one key greenhouse gas called hydrofluorocarbons, or HFCs, and they could be controlled under the Montreal Protocol in much the same way that CFCs are controlled now, and there is an effort to do that now. That's actually the only good news I've seen in the climate negotiations in 25 years. If this is done, I think it will be done, this will be good, it'll work. I'm sure it'll work. And now we need to find other examples like that, okay? And I've proposed some for aluminum, aircraft, or lots of different sectors. It's a very different approach than we've taken so far. It's focusing on sectors, individual gases, smaller agreements, not one big grand agreement. It's not relying on enforcement in the way, or virtuous behavior in the way that the climate talks have so far. Instead, it's bringing about coordination. So the main point I want to leave you with is that the international system is simply not good at cooperation. The only way we could change that would be if we were to give up some sovereignty, which we may be willing to do. We have done it somewhat in the past. We may be willing to do it. I'm not banking on that. I think those kinds of changes will come about very slowly, and they basically require a convergence of values worldwide. That doesn't happen instantly. If you had a certain catastrophe, yeah, we would coordinate. But absent that, I think you're going to see the same thing over and over again we've been seeing so far, countries meeting over and over again, agreeing, and then not actually making much of a difference. However, if you also look at the whole range of international interactions, what the world is exquisitely good at is coordinating. We do it all the time. You don't actually hear about it very often because it works. But we're very good at that. So why don't we look for more opportunities for coordination? That's the main thing I've learned from studying international relations for 25 years. The world is good at coordination, bad at cooperation. Cooperation in the sense of confronting the prisoner's dilemma head on. So let's look for more opportunities for coordination. Thank you.